Okay, starting the next chapter, we have area, the region bounded by a square with sides of length 1 unit of measure on each side. So down below you can see we have a square where each side is 1 centimeter, so the region bounded by that is called 1 square centimeter. Another way of writing that is 1 square centimeter. So we'll do a few problems. First of all, we'll state the formula for the area of a rectangle, and I can show you in a few minutes, a few seconds, how we develop this formula. You have the area equals the base times the height. The base of the rectangle is any one side of the rectangle, usually stated as the bottom of the rectangle, so we could have, say, this segment down here as the base. The height, therefore, has to be perpendicular to that, so we'll say that side is of length 2 is perpendicular. So if the top segment is 3, the bottom segment is 3, and we have the formula states the area equals the base times the height. So if the base is equal to 3 and the height is equal to 2, the area is equal to 6. So if the base was 3 centimeters and the height was 2 centimeters, the answer would be 6 square centimeters. Like that. Now, the way in which the formula is developed is we take the rectangle and divide it into, we draw segments of length 1 centimeter on each side, therefore dividing the rectangle into 6 squares. The area of each square is equal to 1 square centimeters. So therefore we have 6 of those, so we have 6 square centimeters for the area of that rectangle. So for the next rectangle, we have the formula is the area equals the base times the height. Now I'd suggest you always write down the formula, even though it seems very repetitious, because as we go through the rest of the chapter, we're going to be dealing with a lot of other formulas for example, the area of a triangle, the area of a trapezoid, the area of a circle. So my suggestion is you always write down the formula to start the problem. Then you fill in the values, and you have the length of the base, which is 10, times the height, which is 6. 10 times 6 gives you an area of 60. Next problem. Now, as we've seen other problems, the lengths might not always be rational numbers, but the formula still applies. The area still equals the base times the height. The base is any one side, so most people like to consider the bottom to be the base, which is the same as the top. And the height has to be perpendicular to that, so that's 2 times square root of 2. And we carry out that multiplication. 5 times 2 times square root of 2 times square root of 2, if I rearrange everything. 5 times 2 is 10, square root of 2 times square root of 2 equals 2, and 10 times 2 equals 20. So we have that answer. Next problem. If the area is known, we still use the same formula, area equals base times height, but now under A we put 40. The base is 8, same as the top segment, and x is the height. So if 8x equals 40, we divide each side by 8, and we have x equals 5, which is the answer to the question. Next problem. Sometimes we don't know the height, so we have to go off to the side and find the height. In this case, because we've drawn a diagonal for a rectangle, it forms 2 congruent right triangles. For triangle BCD, we have a squared plus b squared, the sum of the squares of the 2 legs, equals the square of the hypotenuse. So that gives us 25 plus x squared equals 169. We subtract 25 from each side of the equation, and we have x squared equals 144. So we take the square root of each side and we have x equals 12. That's the value for x. So now we still have to find the area. So we say area equals base times height, and the base is equal to 12. The height is equal to 5, so the area is equal to 60, which is the answer to the question. Next problem. Very similar to the previous one, we have a right triangle within the rectangle, so we can solve for x first. We have 5 squared plus x squared equals 10 squared. Now if you recognize it as a 30-60-90 triangle, that's great. It saves you some time and effort. If you're not sure, you just use the Pythagorean theorem as I'm doing. And you have 25 plus x squared equals 100. And you subtract 25 from each side, gives you x squared equals 75. And you take the square root of each side, we get x equals the square root of 75. But that has to be simplified, so we say x equals square root of 25 times square root of 3. And we have 5 times square root of 3 is the value for x. The area equals base times height. So the base is the 5 times square root of 3 times the height, which is perpendicular to that, gives you an area of 25 times square root of 3, which is the answer to the question. Next problem. We have area equals base times height. So now we have the area is equal to 80. The base is 8 times square root of 2, and the height is x. So we just solve for x, same as the previous problem. We divide by the coefficient in front of that, which is 8 times square root of 2. And we have x equals that expression. But that's not in simplified radical form. So we'll go down below and simplify that. We have 80 over 8 times square root of 2. 8 goes into 80 10 times, so we have 10 over the square root of 2. But we can't have a square root symbol in the denominator, so we rationalize the denominator by multiplying by the square root of 2 over the square root of 2, and we get 10 times square root of 2 over 2. But then 2 goes into 2 once, 2 goes into 10 5 times, and we have x is equal to 5 times square root of 2. Next problem. Now we know one segment in the diagram, and we want to find the area. But that segment is also the hypotenuse of the 30-60-90 triangle. BCD, for example, is a 30-60-90 triangle. So if we look at that triangle, if the hypotenuse is equal to 12, then the shorter leg, which is opposite the 30-degree angle, has to be half of that, which is 6. And the longer leg, which happens to be the base or the segment at the bottom of this rectangle, that's equal to the shorter leg times the square root of 3. So we get 6 times square root of 3. So now we can find the area by saying area equals base times height. The base is the 6 times square root of 3. The height is equal to the 6, and that multiplies to equal 36 times square root of 3, which is the area. And that's the answer to that question. Next problem. If you have an odd-shaped geometric figure, such as an L-shaped room, and it's going to have carpet installed, a diagram of the room is shown below. How many square yards of carpeting will be needed to complete the job? All corners are right angles. So we don't have just one simple rectangle here. We can divide it up a couple of different ways. We can extend, let's get a different color here. We can extend this line across forming a rectangle at the top and a rectangle at the bottom, or we can extend this vertical segment straight up and we have a rectangle on the left and a corresponding rectangle on the right. It doesn't matter as long as you have non-overlapping regions and you're not missing anything. So we might as well leave it like what we have right now. And the rectangle on the left, okay, we don't know the length of the top or the bottom, but we can find that because if this segment over here is 4, the segment in here is 4, if they have to total 10 across the top, that means 10 minus 4, or 6 is the length of that segment for the rectangle on the left. So the area of the rectangle on the left, base times height, the base is equal to 6, the height is equal to 6.5. 6 times 6.5 is equal to 39. So that's the area of the rectangle on the left. The rectangle on the right, area equals base times height. The base is equal to 4, the height is equal to 9. That area is equal to 36. 36 added with 39 on the left gives you a total area of 75. They'll need 75 square feet of carpeting if it's measured in terms of feet, square yards of carpeting if it's measured in terms of yards, which it probably is here. Okay, one more problem. One wall of a room is going to be painted. What is the total surface area that will be painted in terms of square feet, which is very important on this problem. The wall includes 2 windows that will not be painted. Okay, the dimensions of the room and the windows are given in the diagram below. Okay, so if we don't want to paint over the windows, we have to subtract 2 rectangles from a larger rectangle. So for the larger rectangle, the dimensions are 14 by 8. So we have 14 times 8 is the area of the entire wall, including the windows. The area equals 112. But we have to subtract each window. Well, the dimensions for the window are given in terms of inches. So it's 30 inches by 48 inches. We don't want the answer in terms of square inches. We want everything to be in terms of the same unit of measure. So I'm going to go off to the side and take 30 and divide it by 12 and find that in terms of feet, 30 inches is equal to 2.5 feet because it's 12 inches per foot. And I'll do the same for the 48 inches for the height of that rectangle. 48 divided by 12, it's 48 inches divided by 12 inches per foot, gives us 4 feet for the height. Now when I take feet times feet, I'll get square feet for the area of the rectangle. So the rectangle, instead of using the 48 and instead of using the 30, we'll use the 4 and the 2.5 respectively. So the area of one rectangle, one window, is equal to 4 times 2.5, which equals 10. But we have two rectangles representing 2 windows, so the area that's going to be painted is 112 minus the first window and also minus the second window. So therefore we have 112 minus 20, which equals 92, which is the square footage. 92 square feet is the answer to the question. Hope all of this helps. Good luck.